Welcome to this episode on T1.api, the automation solution for T1. In a previous video, we saw how T1.api allowed to drive the T1 measurements using HTTP requests. Now we'll see how it can be done with a Python script using the T1.pySdk. With the T1 host software version 3.6.0, an example folder is created, by default in C, T1. With previous version, this example folder is in the installation folder of T1, by default in C, Program Files, Gliwa, T1. In this example folder, the next folder Python contains a zip archive. After extracting its content in a suitable location, let's have a look at the files available. The readmes should be the first elements to read. It describes each user scripts. The file requirements.txt lists all the necessary Python packages for the T1.pySdk to run. The folder utils contains handwritten utility functions, allowing to interact with the T1.api easier, such as some polling functions to handle asynchronous endpoints. A help file is also provided, T1.pySdk-chm. This file contains information on the usage of the T1.pySdk, in particular the endpoint association with the Python functions. Some workflows are also present to help with the asynchronous job handling and different use cases. Finally, the folder contains user scripts to start using T1.api. T1.api example can be used with a standard T1 timing license and a target integrated with the T1 target software. It shows how to load a T1 project file, and link with the associated target, how to run focus measurements to obtain multiple timing results from tasks and ISRs and generate a system report. T1.api parallel can be used with a standard T1 timing license and a target integrated with the T1 target software. This advanced script uses threads to measure as many elements as possible in parallel. T1.api stack example can be used with a T1 stack license and without a target. It performs a T1 stack analysis and generate a CSV summary. T1.api streaming example can be used with a T1 timing and T1 streaming license, with a target using a communication bus allowing streaming. It streams raw data for a certain amount of time, then reinterpret the raw trace and generate a system report. T1 symbol analysis can be used to measure all code and data symbols of a project. This script is very useful to start a complete timing analysis of an application. It has a dedicated README for its configuration. Before starting the user script, let's start the T1.api using T1.console.exe, located in the installation folder of T1, by default C, Program Files, Gliwa, T1. The README document an alternative method using the COM object registered with the installation of T1, enabled with the argument -c. Now that T1.console.exe is running, let's try the T1.api example script, using the argument -t to provide the T1 project file path, as documented in the README. The script first loads the project and links with the target. After that, it provides information on its action. Here it starts measuring on the core 0 all the tasks followed by the ISRs. It will do that for all the cores of my target, which is an Infineon TC275 with 3 cores. The example script shall be a starting point to help developing new automation scripts. Also, the utility function can be modified as needed. It is even possible to control the timing measurements and the test environment from single script. For example, if the target is running in a hardware-in-the-loop system, it is driven through multiple test case sequences, influencing on the inputs and the load. It can be interesting to make multiple measurement phases following the different test case sequences, and compare them. When the script is finished, the output is located in a dated folder created under API example, which contains an HTML report, with all the timing results retrieved during this run. Finally, the folder T1.pySdk contains Python code, generated using the T1.api model, of the installed T1 host software. This code is specific to the version installed and should in general not be modified or transferred on a machine with another version installed. The generation has been done, using the tool CodeGen Swagger, by parsing the T1 API model, when it is running on localhost. It is possible to generate the client code for any language supported by this tool. Do not hesitate to contact us if you have any question on this generation. Thank you for watching this episode on T1 API, the automation solution for T1.